Hi everyone, today we're going to talk about the different forms of linear equations and how to write those different forms of linear equations. I know your notes say slope-intercept form, but we're also going to talk about standard form and point-slope form. Slope-intercept and standard form are the two main forms that we use. Point-slope is just kind of a helpful form that we can use to get us into slope-intercept form a little easier with a little less work. All right, so slope-intercept form is the one that we're the most familiar with, y equals mx plus b. This is the form that we see the most often for graphing and for other function uses. When we write equations, we can write an equation in slope-intercept form no matter what information we're given. If I'm given my slope and my y-intercept, I can just plug them in. If I'm given my slope and a point, the point is the x and y, I can then solve for my y-intercept and then write my final equation. If I'm given my y-intercept and an ordered pair, I can then find my slope and then plug everything in. So there may need to be some work required, but I can always use this form, no matter what information I'm given. Standard form is one that we don't necessarily directly write. We usually have to have it in slope-intercept form and then convert it to standard form. Standard form should also look familiar from last unit. We use this a lot to find our x and y intercepts for easy graphing. If I want my x-intercept, I cover up the y term. If I want the y-intercept, I cover up the x term. Right? So that should be familiar from last unit. When we write something in standard form, the coefficients a, b, and c must be whole numbers. They cannot be fractions, they cannot be decimals. And a has to be positive. So that's how we have to make sure, those are the rules we have to follow when we write things in standard form. Point-slope form is just, it's a form that's great to use when you're given a point and the slope. Then you can convert it to slope-intercept form. So the x1 and the y1 are the given point, the ordered pair. M is your slope. So I can just substitute them in, and then I can convert my equation to here. And so as we work through today's notes, I'm going to kind of bounce back and forth between starting with point-slope or starting with slope-intercept. And you're going to see that through the process, we can, no matter which way I start, I always get myself back to y equals mx plus b. And you will pick the way you prefer. If you don't want to have to memorize a third equation, then don't worry about point slope. Do everything through y equals mx plus b. If you really like how easy point slope is, memorize it and then use that one. It's up to you. All right, so example 1, we're going to write the linear equation for a line that goes through the point -3, 2 and has a slope of -1/3. So because they gave me a point and the slope, I'm going to use this form here first. So I'm going to start by writing that down. And I'm going to now substitute in my values, the -3, 2 and the -1/3. So -3 is my x1, 2 is my y1. And then the -1/3 is my m. So I'm going to start by substituting those values in. There's my 2 for my y value, my -3 for the x value, and the -1/3 for the slope. All right, the first thing I see here is these double signs, and you know how much I hate double signs. So I can easily push those together into one sign. Two negatives make a positive. So I'd much rather have one single sign there than have two double signs. All right, now the next thing we need to do is start to solve, or not necessarily solve, but we want to get it into slope-intercept form. That means I need to solve for the y. Right, so first thing I do is I see I have these parentheses, I'm going to distribute. I'm going to give my -1/3 to the x, and then I'm going to give my -1/3 to the 3. All right, so when I do that, -1/3 times x is -1/3 x. -1/3 times 3. That might be one that we're not able to do quite as easily. So I can come over here to my calculator, right, and I just happen to have Desmos up. So if I want to put in -1/3, I can do my negative. To put the fraction, I'm going to hit division, and then 1 over 3. Get out of my fraction, times 3 gives me -1. All right, so now I can go ahead and I can bring everything down. Brought my y down, my -2 down, the -1/3 x, and then the -1. All right, now the last thing I have to do is just bring this -2 over here. Since he's a constant, when I go to add him, I have to add him to the constant term over here, which is the 1. So I'll add 2 to both sides. Oops. And then once I've done that, these here will cancel out. And we are left with y equals -1/3 x plus 1. So I brought my y down, my -1/3 x down, and then I did the math problem, -1 plus 2. Now I have my equation in slope-intercept form. I started with point slope, substituted my values, converted. Now we want to take that same information and we want to write our equation in standard form. The easiest way is to start with the slope-intercept form. So I'm going to start with that, and now I'm going to convert it to standard form. Standard form, if we remember, has both the x and the y terms together on one side and the constant term on the other side. So when I come down here, I need to get my x over here with the y. I'm going to do that by adding 1/3 x to both sides. Now I don't actually add these together, they're two different terms, so I cannot add them together. So I'm going to do this. All right, these over here will cancel out. And all I'm going to do is bring down my 1/3 x plus y equals 1. I'm going to get rid of that for a second, and there we go. All right, now remember our rule. Our rule up here said that a, b, and c must be whole numbers. I can't have fractions, but I have a fraction. So I need to undo this fraction. So remember, to undo divide by 3, I need to multiply by 3. In this case, I have to multiply the entire equation by 3, though. I can't just multiply this by 3. I have to multiply every single piece by 3. So I'm going to do 3 times 1/3 x. I'm going to do 3 times y. And I'm going to do 3 times 1. All right, when I do the 3 times 1/3 x, again, I can go to my calculator. And I can do 3 times, make my fraction for the 1/3, and we get 1. So 3 times 1/3 x is just 1. 3 times y is 3y. 3 times 3, or 3 times 1 is 3. So my equation is going to be x plus 3y equals 3. Remember, I don't write the coefficient 1. He stays invisible. So now I've converted my equation from slope-intercept form to standard form. All right, now I want you to come down here, and I want you to do the same. You start with slope-intercept, start with the point slope, convert it to slope-intercept, then convert your slope-intercept to standard. Go ahead and pause the video now. Okay, let's go to the next page. All right, now we're going to write a linear equation for a line that goes through these 2 points. All right, we're missing 2 pieces of information here to write our equation in slope-intercept form. We need a slope and we need a y-intercept. Even if I wanted to use point slope form, at this point I can't because I don't have slope. So no matter what method I want to use, I have to find slope. So the very first step here is to find slope, and we're going to use our slope formula. So if we remember that from last lesson, we have this slope formula right here. And remember, I said that we would label our points as x1, y1, x2, y2. Right? This is my first order pair, my x value from the first order pair, y value from the first order pair. X value from the second order pair, y value from the second order pair. I'm going to take these values, substitute them in. So I have this math problem. I've got the -7 minus 3 and then the 4 minus negative 1. I need the subtraction and I need the negative. All right, well now I can go to my calculator and I can put that whole problem into the calculator. So I'm going to go, since I want a fraction, the whole thing's a fraction, I'm going to hit division, and I can do negative 7 minus 3, and then 4 minus negative 1. And it equals negative 2. So my slope here is negative 2. All right, now that we have slope, we have a choice. We can use our point slope like we did on the previous page. We have two different points. We can pick one point, and we have our slope. And we can put them into point slope and then convert to slope intercept. But because I want to show you both methods, this time I'm going to start by finding the y-intercept, and then we'll go directly to the slope-intercept form. Okay. So once I've shown you this method, then you can go back and forth between the two. It doesn't matter which one you use. Once you have slope, you can either find your y-intercept and then substitute it all in, or you can use your point slope. All right, so to find our y-intercept, we're going to start with y equals mx plus b. Now, in this case, I don't know my y-intercept, that's b. I have an x value, I have a y value, I have an m value. My x and y, I'm going to pull from either one of these points. It does not matter. I'm just going to pull it from this point here. I'm going to use the negative 1, 3. Okay? So then I've got my slope over here, which was negative 2. All right, so I'm going to substitute everything in. My y value was 3, my m value was negative 2, my x value was negative 1. And now I can go ahead and I can work this out to find b. First, I'm going to simplify. Negative 2 times negative 1, it gives me 2. And now I can go ahead and solve for b by subtracting 2 from both sides. These cancel out. 3 minus 2 gives me 1. All right, so now I have a b value of 1. So my last step then is to write my equation. I've got my slope. I've got my y-intercept. Now that I have those two pieces of information, I can go ahead and just substitute them back into y equals mx plus b. So my equation is y equals negative 2x plus 1. All right. Now, if we want to write this in standard form, I'm going to take the y equals negative 2x plus 1, and then I'm going to convert it over to standard form. So again, standard form has the x and y's on one side, so I need to move the negative 2x over here with the y. So I'm going to add 2x to both sides. That cancels these out. I don't actually combine them. I write them out as two separate terms. 2x plus y equals 1. I double check. Are all three of my coefficients whole numbers? They are. 2, 1, and 1, so we're good. And then I check, is this one here negative, or positive, I mean? It is, we're done. I don't need to do anything more to it. All right, now I want you to come down here and I want you to try this one on your own. I want you to try using this method here, using the slope-intercept form to find your y-intercept, and then use your slope and y-intercept to write your equation. After this point, you can pick and choose which method you prefer. Go ahead and pause the video now. All right, last class we also talked about parallel and perpendicular lines. So we're going to bring those back in. Because sometimes you're asked to write an equation of a line that's parallel to another one. So we have to make sure that we remember the information that we have about parallel lines. When we're talking about parallel lines, remember, slopes of parallel lines are the same. And in order to write an equation, we need two things. We need a slope and we need a y-intercept. Or we need a slope and we need a point. So in this case, since we have one equation here, we need to write an equation of a line that's going to be parallel to this one. And it has to go through this point. Right? So the first thing I need to do is I need to identify my slope. So in this equation, My slope is going to be this guy right here, the 2/3. Right? And then because parallel slopes are the same, I don't change this. This is going to stay exactly the same. Now, because I like bouncing back and forth, or for the purpose of our notes, I'm going to bounce back and forth between the strategies of using point slope or using slope-intercept form. I'm going to, this time, start with point slope. Right? So now, I'm going to use my point slope, since I have a point and I have my slope, I'm going to substitute them in to the slope point form. My x1 is 6, my y1 is -2, my m is 2/3. So I substitute in all my values, and now I can go ahead and do the math. So, again, I don't like these double signs, so when I go ahead to go to my next line, I can go ahead and make that plus, 2 negatives, make a positive. I'm going to distribute 2/3 to x into that -6. So again, if we're struggling with multiplying by a fraction, this one's not as easy as, say, 1/3. I can come over here and I can say 2/3 times 6, or in this case, I should say -6. Oops, I missed my 3 down here. And we get -4. So 2/3 times -6 is -4. So when I go down to my next line, I'm left here. I combine my 2 negatives to a positive. 2/3 times x is 2/3 x. 2/3 times -6 is -4. All right, now the last step that I need to do to get this into slope-intercept form is subtract 2 from both sides. It's a constant term, so I need to combine it with the constant term over here. These are going to cancel out. And we're left with y equals 2/3 x minus 6. I like using point slope because it's a little more direct than using this method up here. Point slope's a little more direct. I put in my x, I put in my y, I put in my slope, and then I convert. Up here, I have to put in my slope and my point, solve for b, and then substitute my slope and my b back in. So not quite as direct, but some people find this method to be easier. It's up to you, whichever method you prefer. All right, I want you to come over here and I want you to try on your own. At this point, you can use the point slope form method, or you can use the y-intercept method. All right, you're already given your slope because they want the line that's parallel to this one. Go ahead and pause the video now. Okay, let's go to the next page. Perpendicular lines. Write the equation of a line that's perpendicular to this one and goes through this point. All right, so now we have to do a little more work for our slope. All right, so we're given this equation. They want us to write a new equation that is perpendicular. So now we have to remember what we learned about perpendicular lines. So the first thing we're going to do is identify our slope. Well, when we look at the given equation, the slope is 5. But we don't want to use that slope because we have to write the equation of a line that's perpendicular. So perpendicular slopes, remember we have to switch the sign and flip. So my positive 5, when I switch and flip, becomes -1/5. This is the slope that we're going to use. This is the slope now that we are going to use when we go to do the rest of our problem. All right, now, because I want to be able to give you equal time processing the two different processes, I am going to use the slope-intercept method on this one. Okay? So I have my slope, now I need to find my y-intercept. So I'm going to start with my y equals mx plus b, and I'm going to substitute in the information I have. I have an x, I have a y, I have an m. Substitute everything in, and now I can solve for b. -1/5 times 5, well, let's see what that equals. We can again pull out the calculator, and -1/5 times -5 gives me a +1. So I've done that. 6 is equal to 1 plus b. Now I need to solve for b, so I'm going to subtract 1 to both sides. Cancels these out. Okay. And now my b equals 5. All right, now that I have my slope and my y-intercept, I can now use these to write my final equation. My final equation is y equals -1/5 x. Oh, and I have a typo in here, and that should be, why is this not? Hold on, sorry about that. Now I should be able to fix that. Maybe not. Okay, now I'm able to fix it. So that really should have been +5. Okay, so my slope that we were able to pull, and then I went through, I found my y-intercept, substitute them back in, and now we have our final equation. All right, I want you to go ahead, try on your own. Again, you can use either method here. Once you've established what your slope is, you can either use the slope-intercept form to find your y-intercept and then write your equation, or you can use point-slope to put into point-slope form and convert to y-intercept form. Go ahead and pause the video now. All right, now, let's see how we can write an equation when we're given a graph. All right, now the problem with this is it doesn't have any points, so we have to look for some good points. We definitely have to have a y-intercept, so that's the one thing I always look for first, and then we have to find our slope. So I always like to look for the y-intercept first. There it is, and then from there I'll look for another point that's close. I can either follow my line up, or I can follow my line down. It doesn't matter. If I went up, I have a point right here. If I went down, I've got a point, whoops, right here. Pull that out for a second. All right, so now I have 2 points. My y-intercept I found already, that's 2. So I'm going to write that down because I'm going to need that information. Now my slope, remember, is my rise over my run. So my rise from one point to the next is I had to go up 2, and then I had to run over 1. So my slope is 2 because it's 2 over 1. Can make that a fraction, 2 over 1, and that simplifies down to 2. All right, now I can just put that into y equals mx plus b. So we get y equals 2x plus 2. Done, we've written our equation. Now if I want to convert that to standard form, start with my y equals 2x plus 2. Remember, I need to take this, bring it over to the y. So I'm going to subtract 2x from both sides. These cancel out. I get negative 2x plus y equals 2. Remember our rules for standard form? All 3 coefficients have to be whole numbers. A cannot be negative. And so they're all whole numbers, but A is negative. So I need to fix that. So to fix that, I'm going to multiply the whole thing by negative 1. So again, not just the first term, but every single piece in the equation has to be multiplied by negative 1. When I do that, negative 1 times negative 2 is a positive 2. Negative 1 times y will give me negative y. Negative 1 times 2 gives me negative 2. So here's my standard form equation. All right, I want you to try on your own with this equation here. Find your slope, find your y-intercept, substitute them in, and then convert to standard form. Go ahead and pause the video now. Okay, let's come over to this one. All right, 2 more examples and 2 more try on your own, and then we're done. This time we're going to do perpendicular lines. Okay? Given the following graph, write the equation of a line that is perpendicular and goes through this point. So here we have a graph, and they want us to come up with the equation of a line that is perpendicular to that. Right. Now that's not going to be the exact line, but that's essentially what we're looking for, okay? But my line has to be able to go through this point here. All right, so first thing we have to do, identify our slope. So the slope on this one, again, I need to pick 2 points. I just picked from this point to this point. So my rise, in this case, was -2. My run was 5. So my slope in this case is -2 over 5. So my slope for this is -2 over 5, but we want the slope of a line that's perpendicular. So remember, we have to switch and flip. So instead of being a -2, it becomes +2 as we switch and flip. So now it becomes +5 over 2 instead of -2 over 5. This is the slope that we're going to use for the remainder of our process. All right, so this time I'm going to use point slope because, again, I'm just bouncing back and forth so that you can keep seeing the 2 different methods. You pick the one that you prefer. All right, so I'm going to use point slope. I'm going to substitute in my point. I've got an x value and a y value, and I have my slope value. So I'm going to substitute them all in. And now I can start working through. I need to first distribute my 5/2 to the x and to that -4. So I'm going to pull out my calculator to help me. So I have to do 5/2 times -4. And that equals -10. So I'm going to bring that down. Y minus 5 equals 5/2 x minus 10. All right, now all I have to do is bring this guy here over to here. I can add 5, cancels those out, and we're left with y equals 5/2 x minus 5. So now we've written the equation of a line that's perpendicular to this one and goes through this specific point. I want you to try this one on your own. Again, if you like the point slope method, use it. If you like using the slope intercept method and finding your y-intercept, then use that method. It doesn't matter which method you use here. Go ahead and pause the video now. All right. Last example that I'm going to do with you, and then you have one more try on your own. All right, so this time they want us to come up with the equation of a line that's parallel to this one and goes through this specific point, -6, 10. All right, so the first thing we're going to do is identify our m. So my slope on this one, I'm going to just pick these 2 points here, has a rise of 5 and a run of 3. So my slope is 5 over 3. Because it's parallel, my slope stays the same. I don't change it. So I'm going to keep using that 5 over 3 as my slope. Now, just to show the other method again, I'm going to use the slope intercept form to find my y-intercept of the equation that would go through this point with this slope. So y equals mx plus b. I have my x value, I have my y value, and I have my slope. I'm going to substitute them in, and now I can go ahead and solve. First, I need to multiply these 2 together. So to do that, I'm going to come to my calculator, 5 over 3. Whoops. 5 over 3 times negative 6 gives me negative 10. So now I can go ahead and put that together. Now all I have to do is solve for b. So I'm going to add 10 to both sides. Those cancel out. My y-intercept is 20. So now that I have my slope and my y-intercept, I can do my final step, which is write my equation. So there's my y equals mx plus b. I substitute in my m, substitute in my b, and I have my equation of a line that's parallel to this one and goes through this point. All right, you have one more try on your own. On the try on your own, it says perpendicular here. Cross the perpendicular out. Okay. And I want you to write parallel here. That should be for a parallel line. All right. So just like the previous example, again, you can use the point slope method, or you can use the slope intercept method to find your b and then write your equation. It doesn't matter which method you use. I went back and forth so that no matter which method you liked, you had a few examples of your preferred method. Right. This is the end of the video, and I will see you in class next time.